So for today's panel, we have Thiru, who is a DevRel at Metis, joining. We have Ben from Veridise and Xiaohong from Pi Squared. And also Arman from Veridise, Arman from zkVerify should be joining us as well. So Arman, if you are here, oh perfect, Arman is here. All right, so now we have everyone. Okay, sounds great. So as some more context for this panel is focused mostly on the opportunities that come with x402. So we'll be discussing how requests, proofs, and receipts can move through this flow, and what must be verified at each step, as well as how privacy and compliance can coexist together. So I'm wondering if we can first start off this discussion with an initial round of introductions. So we can start with...
Hey all, I'm Arman. I'm the solutions architect for zkVerify. And I'm currently crafting a lot of new solutions around zk with our zkVerify chain and Horizon chain as well.
Hello everyone. I'm Thiru. I work as DevRel at Metis, and we are building. I'm Thiru. I work as DevRel at Metis, and we are building the AI infrastructure for building end-to-end for AI agents with DATs, our own token standards, and also infra for x402, which includes GMPR and Create AI, which I'm excited to talk about. Yeah.
Hello, my name is Ben. I work at Veridise. We're a blockchain security firm. We audit up and down the software tech stack, and are also working to actively develop lots of automation tools so that developers can keep their code secure on their own.
Hello everyone, so I'm Xiaohong Chen. I'm the CTO of Pi Squared. We built a decentralized payment network for humans and for AI agents. And we are very obsessed with speed and performance, so we put a lot of effort into maximizing throughput and minimizing the latency. And as a result of that, we end up with a very interesting technical solution that is not a blockchain. We call it a facet network.
Yeah, great. Thank you so much, everyone. I'm wondering, just to give some initial context for our audience, if we can discuss about some of the main opportunities or advantages that x402 has compared to some of the other payment protocols that exist. So we can start off with you, Arman.
Yeah, sure. So the new protocol x402 is kind of an extension of the already 402 payment code that we had, and it kind of makes it easy for agentic payments to say, and it has been kind of linearly integrated with blockchain systems thanks to Coinbase and other facilitators who have brought this whole ecosystem around. So it has been quite easy to make agentic payments with that, and so it's kind of enhances the whole process of micro payments, which we have been talking a lot. So in Web3, from the start, we have been talking a lot about micro payments. All these new L2s like Base and Arbitrum Optimism, they have been promoting a lot about that. And with x402, we are just seeing the next phase of it, where you can basically put your APIs or agents to work with some kind of micro payments inbuilt on that.
As you mentioned, it does power. The major key points of x402 is mainly scaling the micropayments and like reducing or removing the human intervention in respect to the payments need itself, because the upcoming AI economy needs the AI agents to create and transact with each other, and that's only can power through x402. And with the x402, the agent-to-agent payments is really easy, as well as it can able to create values with each other. So that's what really exciting about x402.
Yeah, I think kind of more on the security angle of things, what I'm most excited about is just getting specs in early and really thinking about this problem from the beginning in a structured way as a community, rather than having people kind of roll their own solutions that lead to lots of problems down the road. So having the opportunity to make sure that things are clear and well specified and secure in a problem that is often kind of hard. You can make an analogy between these agent payments that are working on APIs that are off-chain with some of the problems that might come up when you're dealing with bridging between chains. So there's a lot of design space on the security perspective that it really helps to have something constructive and clear written down.
So I want to bring up another perspective, which is the user experience, right? So as Thiru says, so I think really this x402 makes agent level, agent to agent transaction much easier, right? So it really opens the door to agentic payments and also to micropayments. And I think that's, I think that really put a challenge on the underlying payment network, right? So because I think we're seeing a new area where there can be a huge amount of transactions, right? So like 100K TPS is nothing, right? I think just, the demand of 1 million TPS, even more, is there, right? So really the question is, are we ready, right? So is Web3 payment ready? And I have to be frank that blockchains, based on how their basic consensus protocol works, they may not fulfill, right, the demand of this super high TPS. And somehow I think there is this very interesting misconception where people think of Web3 and crypto, like Web3 and crypto, they equal blockchains. But actually they're not, right? So blockchains are just one mechanism to do crypto payments. And I think there are ways where we can even do more than blockchain offers, where we can really maximize parallelism. And I think that will be very much needed if you really want to realize this dream of micropayments. Because otherwise, yes, we have x402. It breaks a lot of obstacles, right, in this autonomous payment workflow. But if the underlying payment network is super slow, it has a very high latency, then the user experience is going to be not great.
Yeah, absolutely. So some of the main use cases that come here are especially within micropayments and limiting the kind of the human-to-human interaction and instead enabling for autonomous agents to complete these actions. And as you also mentioned, Ben, there's that kind of community aspect too, because we're all working together towards this protocol, as opposed to say like having everyone concentrate on their own thing. And then as you mentioned, Xiaohong, even if we think about blockchains in general, they're just one kind of mechanism for achieving this, but there's other solutions out there. So appreciate all the insights made from our panelists. And I'm wondering if we can also dive in to some more detail about the requester and also the like responder dynamics. So is there anything that an x402 request should include to be kind of safe by default without having to trust the caller? And at the same time, before fulfilling a request, is there anything a responder should do to verify in order to avoid situations like a double charge or some other kind of malicious intent?
So when we talk about the spender or the requester of the service and the responder of the service who has the service to give back. So when you talk about this, the requester, when it generates the whole input to send to an API call for this agentic payment to start with, it starts by just making a normal API call, and he gets as a response back the payment details which you need to make. And then when the requester make it's kind of a unique ID with each kind of request we make. Along with that, what kind of tokens we want to send, for the amount of tokens, which chain we are sending, all of those. And then at the end of it, we also have the signature for it. And also, as similar as how we handle nonce in the blockchains, that's a unique ID for every transaction. We do the same out here as the requester also sends a nonce with each transaction it wants to make. And coming to the responder side of things, obviously there are a few checks that he needs to make. That if the requester has appropriate balance or not, which is trying to send, for example. And then the facilitator also needs to do some kind of off-chain verification of things. And making it more complicated or making it more production level, we need to also have compliance checks onto these things as well. So responder or facilitator needs to also do a compliance check based on the wallet address of the requester to say as well.
And in this like request response workflow, there's also like something that requires to be checked, which is the expected response. The expected response and the payment workflows are done, and with having this paywall being removed and the expected response, it's supposed to fulfill the request. So this has to be like this alignment has to be solved in like a DAO kind of way, where any APIs or any like agents that provides the service to this 402 had to be moderated in such a way that it's not like misused in such a way that without having like experience or like used this particular service, they would not know like what the response would be. So there's a like a solution that is required in such a way that the response will be like moderated, and they make sure the request is fulfilled in a right manner.
Yeah, I think safe by default is definitely what we want, and something that's going to be very challenging to develop over time. So the concern about a double spend attack is kind of as old as blockchains. This is the whole reason we have consensus algorithms, to make sure that somebody isn't giving two different servers the same type of signed payment ahead of time. And there's a lot that needs to be done. So if you are accepting as a server a signature for a transaction, you really need to either accept that sometimes those payments aren't going to go through, or you need to have some sort of additional information or leverage over the person that is requesting this and sending you this sort of pending payment. So this is a great space for KYC approaches, or especially to rely on on-chain solutions where contracts can provide you some kind of temporary escrow. The other thing that I'd really think needs a lot of thought and examination is in the payment scheme itself. So as much as possible, we want the signed transaction to be bound cryptographically to this specific request in a way that is privacy preserving, and also so that the server doesn't conflict with itself. It's very difficult sometimes to manage nonces correctly, or to track if somebody is requesting multiple services from your server at the same time and trying to get one payment credited for both. So making sure that we take sort of a hash everything approach is, may sound like overkill, and often takes a lot of care to make sure we're not ruining performance, but taking advantage of structured hashing techniques and the lessons we've learned from prior signature-based payment systems is going to be critical. The last thing I'll mention is just that dealing with these AI agents is something that's very dangerous on both ends. So you've seen research recently with like these MCP protocols where prompt injection can be a serious issue, right? The x402 payment does include a description from the server. So that is a new angle where somebody can feed in prompts or instructions to AI agents that may lead to problems for you. So making sure that we are very careful to understand what data sources these AI agents have interacted with before they even get to the request stage is already going to be a challenging problem that needs to be faced.
I totally agree with Ben on the double spending, right? So one of the most fundamental critical issue, and actually that is why we have consensus protocols and so on. If you look back in history, right? So Bitcoin had this idea of, we need to prevent double spending, and how can we do that? Well, let's have a total ordering of all the transactions everyone ever makes on the network. And that's a way to avoid double spending, because once you spend a coin, right, you cannot double spend it again, because everything is total ordered. And later, I think Ethereum, right, so they took the idea and they generalized on the programmability side, right, so they make it Turing complete and so on. But on the consensus part, they still inherited this concept of, well, I have to have a total ordering of all the transactions on my network so I can prevent double spending, okay? Well, the problem with that vision is it puts basically a global lock on the blockchains, right? It's a bit irony in the sense that we're talking about a decentralized system here, but we make it, we let it run a consensus such that it behaves as a world computer, as a single-threaded computer. So it's like, you have a full decentralization, but with hands tight, tight. So the interesting here is 5 or 6 years ago, right? So there's this amazing scientific results showing us that you can have a mathematically sound payment system with no double spending without such a total ordering of transactions. You can have a payment network where validators do not even need to talk to each other, let alone saying that they have to agree on a single load of all transactions, but you can still have a very sound, robust payment network without double spending. And that really maximizes parallelism. So that is I would say it's one of the major fundamental breakthrough on the consensus level, right? So it really opens the doors to Web3 payments. Why? Because it unleashes the capacity of TPS, right? So by allowing payments to happen spontaneously and in parallel, I think that's really the future where micropayments and agentic payments are.
Absolutely. So you see some opportunities with parallelism here. And from the other panelists, you guys mentioned for the facilitators the need to be compliant, but then also be moderated. And then, as you mentioned also, Ben, we can take some of the prior lessons that we've learned from the signature-based protocols, but of course there's some new considerations that we need to make with these agents, for example, with the prompt injections. So all of these points are really great, and yeah, I appreciate you guys for making them. I'm also just shifting this conversation towards ZK. Curious to hear if there's any kinds of opportunities where ZK can further extend x402, like for example, any kinds of privacy preserving but verifiable payments, say that you want to conceal the sender, the recipient, or like the amount that you're trying to send, or even in cases where we can not have these trusted central facilitators be involved, like say Coinbase, and instead provide a more verifiable way without having to have this third party. So very curious to hear from your guys' perspective if you see any kinds of new opportunities where ZK can further extend this protocol.
Yeah, so coming to the ZK side of things for something like x402 or the agentic payments, there are three main broad scopes I see out here. First is obviously the compliance side of things. As I told, the responder or the one who is providing the service needs to do a compliance check, because now it's maybe not a big scale out there, but once we grow big out of our bubble, governments will obviously try to enforce the compliance on us. And it similar to how blockchain tries to handle compliance with zk KYC through zk passports. We have new zk ID cards coming up, so similar to Anon Aadhaar in India, and Bhutan's NDI card as well. So with all those new zk ID protocols coming up, I see a very growing phase into agentic payments as well, where alongside the payment, we also request the zk details of the KYC, that you are not in the OFAC list of US, for example, that you are eligible to do this transaction and you are not a blacklisted address. And the second broad scope of ZK out here is similar as how we see private payments in blockchain growing day by day. There would be also a need of private payments in agentic AIs as well. So every agent, as we see in further, maybe have IDs out there, but maybe the agent owners don't want to leak which API or which agents they are talking with, for example. So there will be a whole new scope of privacy preserving talks between the AI agents, where we talk with each other but privately. We make API calls without exposing which agent I am, but I can say that I am agent A with this reputation score and I'm eligible to make this call. And the third is obviously the facilitator. As you told, it's a centralized service right now, and we need to make it more foolproof. And there are many ZK protocols and ZK frameworks which can be helpful out here. So Brevis as a co-processor is a very good example and can be fruitful in some parts of the facilitator frameworks as well. So as we grow further in the space of agentic payments and x402, I see compliance, privacy payments, and then ZK-based facilitators coming along very soon.
So those are really good points, and especially with respect to the agent payments as well. And agents, of course, have wallets if they want to like do the x402 payments, and having wallets for the agents, and these wallets also need to have the privacy for the transaction, because it also have the scope of getting like vulnerable attacks, especially with the agents are also run through some other LLMs. So there's a like a security vulnerability. So especially to solve that, even the GMPI that built by Metis, we use the ZKM for the facilitator, and which also helps to minimize the trust and also makes it a decentralized fashion. So in order to reduce the vulnerability for agents having wallets, the transaction had to be private. So if a particular service knows that this wallet have this much of fund, there's a higher possibility of it get exposed or compromised through some injection attacks. So these are like really inevitable features that is required, and we at this point I don't think we have any solution that solves it end to end. Yeah. So this is our something we are looking forward, and especially with respect to solving the privacy for agent's wallet. Yep.
Yeah, this is a great question. I completely agree is that the identity is a huge component of what ZK can bring to this system in a way that's going to make the whole thing safer. Making sure that you are interacting with somebody who has not already been attempting to avoid making payments, who is on sanctions lists, making sure somebody isn't trying to use your x402 server as some kind of relayer for whatever attacks, making sure that you in some way can be positive of this person is not a malicious actor is a great role that ZK can have without completely ruining privacy. I think the payments is actually very tricky, right? Because right now we have these kind of to and from addresses, and just being able to see that, for example, there's very high traffic to a particular address might give you information that you don't want to leak about how successful or not your server is, right? If I'm running a x402 paid service, I maybe don't want my competitors to be able to know exactly what's making a lot of money, or that maybe I'm stalling out right now and I'm trying to figure something out. So making sure that not just the addresses are obfuscated from somebody, but actually using a private payment protocol is going to be essential to keeping that kind of information off of the chain.
Yeah, I also agree that privacy is definitely a big thing, right? So, and this is where the ZK technology can really help. I think actually it's a shame that I speak last, because this is a topic I'd like also to hear opinions from the other panelists. I see two angles we can push here. So right, one is to start to build in some of these ZK features, privacy stuff into the x402 protocol itself. And the other is to kind of delegate it to the existing services, right? For example, there are blockchains and payment networks like our Facet and Zcash and so on. They do have this shielded transactions, so they do have this privacy protection built in. So in a sense, x402 can follow a simplistic design, right? It does not need to have any of this ZK functionality built in, because that would make the protocol a bit more complicated. So our team, we've been integrating x402, and it's a very smooth procedure, and I think that really shows how good a design the current x402 is, because it's very simple, right? If we start to add ZK at the protocol level, my concern is that, one, it adds a complexity that maybe not everyone needs, right? I totally understand there are use cases where privacy is a must and so on, like the compliance proof, and also this shielded transactions, identity, and so on. But there could be many other cases, especially microtransactions, right? So I just want to transfer the money, right? So the faster the better. And if we start to add in ZK components, that's a necessary component. That I think will inevitably increase the latency, right? Because the ZK proof generation is much more expensive. So I'm not sure, right? So I think we have both directions open here. But in my view, I would like to see at least things. It should be like an option, right? So you can opt in, and if you want to get more privacy, or you can pick the fastest route if you care more about throughput and high TP and so on.
Absolutely. So we should offer users the flexibility to choose if they want to opt in or opt out to using ZK. As you mentioned, there's some use cases, for example, where ZK may not be needed if they say want to send these fast micropayments, versus something where if it's privacy preserving or compliant or anything identity related where ZK may be needed, then users will have the option to say like opt in and out of that service. But thank you so much for all of our panelists for joining us on this discussion today. I think this is the first panel as well with the main topic for x402. So hopefully we can have more panels like this in the future. And appreciate, again, all of you guys for being here. Thank you so much.